Welcome Julian to another video lesson. So we have 4 problems tonight, 10, 11, 12, 13. Number 10 is the one, of course, we were doing together. We have to leave it midway. I'm going to show you how to finish it off. And numbers 11, 12, 13, they are very similar. There's something that you need to know I'll talk about. But before that, as I said, number 10. The second angle in this triangle is 1/3 as large as the first. The third angle is 2/3 as large as the first. Find the angle measures, draw a possible picture of the triangle. So I think we both agreed that if an angle is 1/3 as large as another one, then the first angle is more, right? So I'm going to start at the same point. Let's say the first angle in the triangle is x. Then the second angle, which is 1/3 as large, must be 1/3 x. And similarly, the third angle, which is 2/3 as large as the first angle, must measure 2/3 x, right? Now what's x? X is the measure of the largest angle in the triangle. So these three are all measures of the angles in a triangle, and therefore they have to add up to the sum of the angles in any triangle, which is 180 degrees. So we need to solve for x. This is an equation in x. We need to solve for x. There's only one x that will fit in, so that you take that number, you take 1/3 of that number, you take 2/3 of that number, you add them up, you get 180. The question is, how do we solve this? Well, if you look at x, x is nothing but a 1x, right? So then what if I were to ask you, hey Jillian, can you add one apple and another 1/3 of an apple and another 2/3 of an apple together? What do you get? Or for example, let's say one whole pizza and another 1/3 of a pizza and another 2/3 of a pizza, right? You get my point? So basically it's about adding these fractions up. 1 is not a fraction, but you can always write it down as a fraction, as 1/1. So this is going to be 1 plus 1/3 plus 2/3 of an apple, of x over here, right, is equal to 180 degrees. Now the sum of these three, it's pretty easy to guess actually. 1/3 and 2/3, like you were saying, they add up to one whole. So this portion being one whole, we have another one whole, so that makes it two wholes. So we have 2x is equal to 180 degrees, and the rest, you know, is a piece of cake. X is going to be equal to, divide with 2 on both sides, you get x is equal to 180 degrees divided by 2, which is 90 degrees. So we have the largest angle in the triangle is 90 degrees. The other two angles, well, 1/3 of x is 1/3 of 90. So we could say 1/3 of x is equal to 1/3 of 90 degrees, which is 30 degrees. And the third angle, you actually have more than one ways of doing it. You could either go ahead and find 2/3 of 90 degrees, or you could simply subtract 90 and 30, the sum of 90 and 30 from 180, because it's like a triangle. So we have our triangle over here. There's 190 degrees, there's another 30 degrees, and we need to find this one. So like I said, the three have to add up to 180, so this has to be a 60 degrees. Or you could do 2/3 of x. Now that you know this is how the triangle is going to look like, it can be of different size, you know. That's why they said draw a possible picture of the triangle, because you can have an infinite number of triangles with these angles. So they could start from the tiniest of the triangles and go all the way up to the end of the universe with a 30, 60, 90. So this is just one possible picture of the triangle. It could be of any size. Now that said, who wants to work with fractions? Even you told me I don't know how to do this with fractions, right? So I have a better way to deal with this equation, and I'll show you how. Look, the second angle is 1/3 of the first one. So 1/3. Instead of using a fraction, why not we start with a 3x for the first one. Now why we are doing that is because if the first angle is 3x, 1/3 of that, 3x has got 3 x's in it. So 1/3 of that is simply going to be a x. And 2/3 of that is simply going to be 2x. So in that case, these are my three angles, 3x plus x plus 2x, and they add up to 180. Now compare this equation with this equation. Given the choice, which one would you like to solve? Obviously this one, right? The one without the fractions. So we have 3x plus x, that's 4x plus 2x, that's 6x is equal to 180 degrees, and therefore divide both sides with 6. You have x is equal to 30 degrees. Now what's x in this problem? X is this angle, so we have this angle as 30. We don't have a different answer. It's not like x was 90 over here, x is 30 over here. This time x is this angle, the smallest angle, and that's 30. Therefore 2x will be 2 times 30, and that's a 60. And 3x is 3 times 30, or you could subtract the sum of 30 and 60 from 180. Either way, this is 90. So it's still a 30, 60, 90 triangle we have over here, right? Now it's your choice which method you want to do, fractions or this one. Let's move on to the next set. Tell whether a triangle can have sides with the given lengths. Explain. Now the question is, can we have a triangle with any given side lengths? Anything is possible. So let's say I want to draw a triangle that has got a 10 centimeter side, let's say a 3 centimeter side and a 4 centimeter side. Can I draw a triangle of these side lengths? Let's find that out. So to begin with, what I do is I draw a line that's 10 centimeters long. Pretend that this line is 10 centimeters long. I'll drop the unit for convenience and I'll just write a 10 over here. Now these are the endpoints. Now from one endpoint I need a 3 centimeter line, right? Now that 3 centimeter could be any line as long as it's 3 centimeters long. So it could be like this, it could be like this, it could be like this, it could be like this. As long as these lengths are 3 centimeters, it's fine. I can have that in any direction. There's no constraint on the angle. It could also be like this. It could be an obtuse angle, this angle, right? As long as that's 3 centimeters. So what I could tell myself is, so it appears that if I were to have a circle of radius 3 centimeters starting at this point, which would probably look somewhat like this, I'm guessing. I know it's not a circle or probably not centered at that point, but pretend that it is. So the radius of this circle is 3 centimeters. So this is 3. Now I need to do the same thing on the other side, but this time I'll have a circle whose radius is 4 centimeters, because my 4 centimeter length could go like this, could go like this, could go like this, could go like this. You know, as long as the length is 4 centimeters, it should work. So then what I do is I again draw a circle centered at that point, and this time the radius is 4. Now look, this obviously is a line, this is not a triangle. In order to make a triangle, I have to have some sort of an angle over here, some sort, and over here as well. Now the problem is, if I do that, this is also 3, this is also 4. The problem is, it's not a closed shape. There's a huge gap over here. It's not a triangle at all, right? And if you go further up, you should realize that the gap keeps increasing, it doesn't decrease. So if I were to pick the 3 centimeter over here and a 4 centimeter over here, now this gap has even increased. So my best chance is I should make these lines as close to the baseline as possible. But then no matter what I do, even if I were to put it on the base, which obviously will not be a triangle, it would just be a line, but even then the triangle will not be closed because there will always be a gap over here, and the minimum gap, as we see over here, is 10 minus 3 and 4 add up to 7. So we still have a gap of 3 over here. The picture is not drawn to scale. This length doesn't look like the same as this one, but I hope you get the idea. I'm not using a compass, so it's hard for me, and I'm not measuring of the lengths, but the triangle is never going to be closed. Now in order to close the triangle, in order to make sure that these two lines, they come and meet at a point so that we have a closed shape, we call it a triangle, we could call it a triangle, is when these two lines meet. Now when will that happen? Now if you bring them down, as we move farther away from the base, the gap increases. So if you want to come close to the base, the gap decreases, and in the limiting case, on the base you want to make sure that this length and this length, they have to add up to the base length, which is 10 centimeters. So these two have to add up to 10, and even that won't be enough. Why? Because if that's the case, the two lines are only going to meet over here on the base. Let me just change the color. So if these two side lengths, if they were to add up to 10, then it would mean that one side will be like this and the other one, starting from exactly here, go all the way up to here. But the moment this is not a triangle, this is a straight line, you have to lift them up in order to make some sort of an angle over here and here. And the moment you do that, the gap comes in, because the minimum gap is on the base. So if you want to make sure the gap is not there, what do we need to do? We need to make sure that the two smaller lengths, they actually add up to a number that's larger than the largest side in the triangle. And this is what we call the triangle inequality theorem. I'm going to write that down for you right now. The moment you understand that, problem numbers 11, 12, 13 will be very easy. So in any triangle, the sum of the lengths of the two smallest sides must be, the sum of the lengths, this plus this, must be larger or greater than the length of the largest side. Correct? Now take a look at number 11. The three sides are 6 feet, 8 feet, 13 feet. Largest side 13 feet. Add the other two up. 6 plus 8 is 14. So the sum of the lengths of the two smaller sides is actually larger. So you'd say 6 plus 8 is larger than 13. Therefore, this is possible. Number 12. The two smaller sides are the 8 centimeter and 2 centimeter. So 8 plus 2 is not larger than 15. It's smaller than 15. Therefore, you cannot have a triangle with these side lengths. Number 13, exact same thing. Largest side is 22 millimeters. Smaller sides are 9 and 14. And 9 plus 14 is 23. That's actually larger than 22. So this works. So this will not be the possible lengths of any triangle. I hope that makes sense. I'll see you soon. Oh, and before I go, there's a name given to this. I forgot to write down the name. This is called the triangle inequality theorem. So that completes it. Take care, Jillian. Bye-bye.